Let us discuss another example for joint probability density function. Suppose we select one point at random from within the circle with radius r. If we let the center of the circle denote the origin, define x and y be the coordinate of the point chosen. Then xy is a uniform bivariate random variable with joint probability density function given by this. So, basically suppose if you consider a circle, it is center at 0, select one point at random from within the circle with radius r. If we let the center of the circle denote origin. So, this is the origin center and circle maybe looks like this, and this is the equation of the circle. We know that x square plus y square is equal to r square, because we are considering this radius is r. So, this is given. So, we are randomly selecting point inside this circle. So, it is a uniform distribution, the joint probability density function. So, x and y be any point here. So, x and y, so any point. So, x and y be the coordinate of the point chosen, then x y is a uniform bivariate random variable with joint probability density function given by this. So, f x y equal to joint probability density function, the joint probability density function of x y is given by f of x y, this is equal to some constant k, because it is a uniform distribution. So, inside this region it is k. So, we will denote by x square plus y square less than equal to r square, then this is k, 0 otherwise. So, this k is a constant we have to find out. Where k is a constant, determine the value of k, find the marginal probability density function of x and y, find the probability that the distance from the origin of the point selected is not greater than a. So, one by one let us find. So, first we find the probability, what is the k. So, here probability density function is non-zero. So, inside the region in the circle, otherwise this is 0. So, k, because probability density function we will check the properties of the probability density function. So, the properties of the probability density where it says that if k can be greater than equal to has to be 0, when p x y probability density function always greater than equal to 0 for all x y. So, that is why k has to be greater than equal to 0 to satisfy this condition. And second condition is that if you take the integration, then that will be equal to over the region over the minus infinity to plus infinity r2, then that has to be 1. This will be equal to 1. Now, this will be non-zero inside the circle. So, basically this is nothing but x square plus y square less than equal to r square integration with k dx dy, this is equal to 1. So, this is a constant. So, it is a even function. So, we will do the integration. So, if you want to find the, so we already know that this because this is nothing but k into integration of x square plus y square less than equal to r square dx dy. So, this integration is nothing but, so this is nothing but the area under the which is implies this area under this circle x square plus y square less than equal to r square, and we know that this area is nothing but pi r square. So, then we can just directly write pi r square, this is equal to 1, which implies k will be nothing but 1 by pi r square, or you can just find out what will be the area. So, that is nothing but you just do the integration here. So, whenever if you take this, so this limit of y will be minus r2 plus r, and it is even number because it is a even function only constant. So, you can make 0 to r also 2 into r, and whatever whenever if you want to take limit of y first, y second last. So, this will be minus r2 plus r. So, this is 0 r and this is 0 minus r, and for any y value. So, then your x value it will go, because it will be nothing but y square is equal to r square minus x square. So, it is nothing but it will be from so y will be plus minus root over of r square minus x square. There are 2 point, it will be for particular y value there will be 2 value. So, this is minus root over of r square minus x square, and this is root over of r square minus x square. So, then your integration will be nothing but so we can, so suppose you want to do the integration dx dy, it will be minus r square minus y square root over. So, x limit we are finding, limit of x. So, we just opposite we did it, y limit. So, then we have to, so x limit will be x square will be root for given y values. So, r square minus y square. So, actually this will be y square and this will be x square y square, and so x will be plus minus root over r square minus y square, given y value actually we are finding. So, r square minus y square. So, this will be nothing but minus r square minus y square to r square minus y square, and then this will be minus r 2 plus r dx dy. So, this will be 2 into root over of r square minus y square and dy minus r 2 plus r 2 minus r. So, this can be represented because it is a even function here y, if you replace y by minus y. So, this will be 4 into 0 to r root over of r square minus y square dy. So, then we have to put some I is equal to maybe r sin theta. So, this if we replace this, then we can do the integration, and then we finally you will find that. So, then what we will get dy is equal to r sin theta cos theta, and limit of theta will be whenever theta is 0, then y will be 0, theta is r, then y will be pi by 2. So, this is nothing but 0 to pi by 2 root over of r square minus r square sin square theta, then r sin theta cos theta d theta. So, then what we will finally we are getting. So, this is r 4 into r. So, r square 2 r it will be coming. So, 1 minus sin square theta will be cos square theta root over of that this cos theta 0 to pi by 2 sin theta. Okay, I did some mistake. So, here actually it will be nothing but r cos theta d theta. So, it will be r. So, r cos theta d theta. So, then this is root over of 1 minus sin square theta cos theta, again cos square theta root over the cos theta. So, this will be 4 r square cos square theta d theta. Now, if you make it is 2 r square 2 cos square theta. So, cos square 2 cos square theta can be represented as 1 minus cos 2 theta, then 0 to pi by 2 this sorry, this is just a integration, you can do it d theta. So, this is pi r square and minus this is sin 2 theta by 2, and if you take the limit this become 0. So, this is coming pi r square. Why we did this integration? Because we need this next problem we have to do it, find the marginal probability density function of x and y. So, what will be the marginal probability density function, how we will find out. So, the marginal probability density function, so note that this is the areas of the circle pi r square we found. So, k become pi r square. So, our density function now the joint probability density function of x y is given by f of x y is equal to. So, now k become 1 by pi r square whenever x square plus y square is less than equal to r square 0 otherwise. Now, we have to find the marginal probability density function of x and y. So, the marginal means we have to find the, so whenever we find subset of the distribution of the subset of a random vector, one of the component of some. So, whenever we discuss the multivariate random variable, there will be many subsets of n number of, here only two only x and y we are talking about. So, that is why the marginal probability density function of x is given by f of x. So, this is by definition this is minus infinity to plus infinity. So, you can remember that we have to take the integration over the other variable dy. Now, for a fixing x, so that is why we did the previous integration, it is required. What will be the limit that this density function will be non-zero? Because we see that it is non-zero whenever x square plus y square is less than equal to r square. Now, for a particular values of x, if you want to find, so then x can be, possible value can be minimum value minus r, maximum value plus r. So if that only it is non-zero, otherwise it is 0. So if actually x is between minus r to plus r for a particular value of minus r to plus r, then it will be non-zero. So then y limit will be, y square will be less than equal to r square minus x square. So y will be greater than equal to minus root over of r square minus x square, less than equal to root over of r square minus x square. So that is why this will be nothing but, so this limit will be, if for this f of x, otherwise this value will be 0, for this region only, this is minus root over of r square minus x square and root over of r square minus x square, then this value will be 1 by pi r square by the definition, then dy. So then only this is the properly, so otherwise if you do any so mistake, then we will not find exactly probability density function. So this limit you have to find out properly. So that's why I because we already know that area of the circle is 1 by pi r square, but we found out here to understand how we will do this marginal. So this is nothing but, now this is a constant, and then if you do the integration of y, you will limit. So this is 1 by pi square, 1 by pi r square, then if you, this is the integration, if you take the limit r square minus x square minus, and this is root over of r square minus x square. So if you put the limit, then you will get that 2 into root over of r square minus x square by pi r square. So hence we will write down properly, otherwise it is 0. So hence the probability, marginal probability density function, hence the marginal probability density function of x is given by f x is equal to what we found, 2 into root over of r square minus x square by pi r square whenever x is between minus r to plus r. So because it is continuous density, you can equal to or just less, the strictly less than, it does not matter. At a point the probability will be 0 and 0 otherwise. So this is the, hence the marginal probability density function of x is given by f of x is 2 root over r square minus x square by pi I r square, when x is greater than equal to minus r, less than equal to r, 0 otherwise. So similarly, so we can find the marginal probability density function of y also. So let us do the computation again. The marginal probability density function of y is given by, so of y, this is minus infinity to plus infinity. In this case we do the integration with respect to x. So now whenever y is greater than equal to minus r, less than equal to plus r, then only this is non-zero, and the limit will be like similarly x square plus y square less than equal to r square, then it is non-zero, and fixing y for y between minus r to plus r. So y square is less than equal to root over of r square minus x square. So for fixing y square, we have to do the limit of x because we are doing integration. So x square will be less than equal to root over of r square minus y square. Hence x will be greater than equal to minus root over of r square minus y square, less than equal to root over of r square minus y square. So that means it is minus root over of r square minus y square, this is root over of r square minus y square, it is a constant pi r square, then d of x. So then if you do the integration, again similarly we will get 2 root over of r square minus y square by pi r square. So then we finally we write the probability density function, the marginal probability density function of y is given by f of y is equal to 2 root over of r square minus y square by pi r square whenever y is greater than equal to minus r, less than equal to plus r, this is equal to 0 otherwise. Note that whether it is a density or not, because it has to be a probability density, you have to do the integration minus r to r and then you can show that it is equal to 1, because we computed the area under the circle and then we found that this integral we have already computed here, similar type of integration. So, you can see that here we already computed like this. So, 2 root over r square minus y square, that we computed minus r to r. So, this is coming nothing but pi r square by pi r square, this will be is equal to 1. So, that is why we did this computation, and this is the marginal probability density function. So, let us see what are the other problems. So, this is find problem marginal probability density function of x and y. Find the probability that the distance from the origin of the point selected is not greater than a. So, then it is asking that distance from the origin. So, this is, so sorry, just okay. So, already we have this image. So, this is now for a anything. So, suppose a any radius. So, distance from the origin. So, what will be the probability that distance from the origin will be not more than a. So, that distance from the origin, how does the distance from the, for any point in the plane, any point, suppose this is x y. So, distance from the origin can be represented by x square plus y square. So, and square root of that. So, this is the distance. So, positive square root. So, whenever we take the square root, so this is positive value. So, this should be less than equal to a. So, it is asking that what is the probability that this should be less than equal to a square. So, we have to find the probability x square plus y square, this should be a square. So, now expect this is nothing but integration x square plus y square less than equal to a square 1 by pi r square dx dy. So, this is by definition, let us write down first definition. This is the density function x y dx dy. Now, this is non-zero if a is less than equal to r, then this is nothing but x square plus y square less than equal to a square, this value will be 1 by pi r square. If x square plus y square less than equal to r square, then only this is 1 by pi r square, otherwise it is 0 dx dy. If a is, so then let us find out this value, because it is a constant and we know that area under x square plus y square less than equal to a square, this area in the circle of radius r square. So, that means if your r square is like this and this circle is like this. So, this is x square plus y square. So, this region is nothing but x square plus y square less than equal to a square, and the bigger region is x square plus y square is less than equal to r square. So, this is nothing but the area under this circle will be pi a square by pi r square, this is a square by r square. Now, if a less than equal to r, then this will be probability is a square by r square. Now, if a greater than equal to r, for a greater than r, the probability that x square plus y square less than equal to a square. Now, in that case, so by definition this is nothing but x square plus y square, x square plus y square less than equal to, in this region we have to do the integration of the joint density function. So, now x square plus y square less than equal to a square. So, a is greater than r. So, this is density will be 0. So, basically this integration can be divided like this, x square plus y square less than equal to r square f x y. So, this is integration is nothing but this is density function dx by dy in the inside the region, plus integration x square plus y square is greater than r square less than equal to a square. So, a is greater than r, that is why. So, this is this density is 0 in this region. So, that is why this is nothing but pi r square by pi r square, this is 1. So, this is plus 0, the remaining is 0, this is nothing but 1. So, for a greater than r, the probability will be 1, and for a less than equal to r, this probability will be s square by r square. So, we have to specify the value, because this is in the problem. So, they did not ask, they did not specify it. So, here find the probability that the distance from the origin of the point selected is not greater than a. So, it is very important that where a is situated. Suppose if you let us try it again to draw little bit better circle. So, this is x square plus y square equal to r square. So, if a is situated a less than r, then the probability that my x square distance will be not more than a, this probability will be the ratio of this area pi a square by the whole area. So, pi a square by pi r square, this is a square by r square. But if a is bigger than this, then there the density will be 0 inside this region. So, though basically this integration will be pi r square by pi r square plus this is the region is 0. So, this will be 1. So, whenever that is why we written already. So, that whenever a is greater than r, then this is 1, if a less than equal to r, then this is a square by r square. So, this is the solution of this problem. So, now we will discuss some other topics. We have discussed 2 numerical example for joint probability density function and 2 numerical example for probability mass functions also, joint probability mass functions also. Now, I hope you have understood the concept of joint distribution and also joint cumulative distribution function of a random variable, bivariate random variable x y, and joint if they are discrete, the joint probability mass functions and their related properties, and we have done some numerical examples. And then if x and y both are continuous, then we discussed joint probability density functions and the related properties and 2 numerical examples. I hope you understand, and you can go through some more problems also. You can solve problem related to these theories. Now, we will discuss conditional probability mass functions. So, we have already discussed some conditional probability of a given event. So, here we will discuss more general, like suppose there are 2 random variable x and y, both are discrete, and one variable observations, what is the observation it appear, it is given to us. Then how the probability mass function of the other variable can be modified. So, it is known as the conditional probability mass function in the case of discrete random variable, both are discrete random variable. So, here you can see that conditional probability mass function, if x and y, x y is a discrete random variable with joint probability mass function x y, x I, y j, then the conditional probability mass function of y given x equal to x I is defined as this function.